It might help if I unmute myself. That's one of those things that,
Yes.
one of those, traps for beginners, All right, let's see. Let's open up the Python here, samsclass.info. Actually, it's already open over here.
Caitlin, I don't know if you need to be the one to record since you're the host.
Oh,
I think I can record it here.
No, Sam, as long as Sam remains host, he can record and stop recording, and we'll be fine.
Okay, perfect. So we're going into the attack techniques for beginners, like usual, and we're going to scroll down to Python, Violent Python 3. So the reason why this is Violent Python 3 is because we're using the third version of Python. So for people that are just getting into Python or haven't used it before, there's a few different versions out. Python 2 was very popular, but it's just been deprecated. You're no longer supposed to use version 2 of Python. So now we're all moving up to Python 3. So let's get Python. So in your web browser, go to Taito.run Python 3. Let's do this. At the code section, enter print hello world. So that's going to print, well, hello world, or any text you want to give it. And then I guess we push run. There we go. And there's our output. So what we did is we wrote some code here. And then we see the output here. And it's down here, we can see how long it took. Let's see, flag 1. So run this code. So the first flag is to run the help function. And for those who are new to programming, a function in C-like languages or in Python is a string of characters followed by these parentheses. And usually if a function has parameters, like let's say you have the function add that takes 2 numbers, you would put those numbers in these parentheses. But since help doesn't take anything, you just have the open and close parentheses right here. So if we were to, for example, print nothing, we printed hello world, nothing, and it ended it with a new line. And as you see, we put nothing in these parentheses. But anytime you call a function, you do need these parentheses. So the first flag is to run the help function. Let's scroll down. Using the network. So in the code section, so we can actually import requests here. Oh, awesome. So the request import, what that does is it gives us the functions to run HTTP requests or do essentially request web pages. And so the way that Python works, everything is divided up into modules. So you only import what you need into your program. In this case, we're going to import the requests module. So we get that functionality to grab stuff from web pages. So we're going to import requests. Then we're going to do requests dot. So this is the way of Python organizing its imports. Get http://samsclass.info. So we're going to grab that request set. And Python's named after Monty Python. So you have things like the Grail framework. At the top, okay, so I guess we're going to put this in a variable R, which is so what happens is that we're running a function called requests, which is part of this import.get. So we're going to try to get a web page and put it into this variable called R. And the web page we're trying to get is samsclass.info, but I imagine we're going to have some issues here. Let's see what happens. So a lot of new programmers get very scared when they see these long error messages, but I have to tell you right now, these error messages are your friends. You want to see these error messages because the more information you get, the more likely it is you're able to figure out what's going on.
Yeah,
So-
and Kate, like I can't emphasize. Sorry, Caitlin, I had to chime in to emphasize that because I've taught a lot of beginning coders, and they see all that text like you see on Caitlin's screen, and they panic, and then they don't read the error messages. So then they just panic, and they're like, it's broken. I don't know what to do. When they are your friend, you've got to actually read them because they'll tell you how to fix your problem.
Right. In this case, we can see that there's an issue here with the sockets. And I'm not entirely surprised by this because, and here we have HTTP connection. They don't know what's going on. Can't connect to port 80, no retries, et cetera, et cetera. For some reason, this website doesn't want us sending malicious requests to other websites. I don't know why that could be. So I believe that's why we're getting all these errors. It looks like they simply made it impossible to run malicious traffic from their Python site here. So we're gonna have to run it locally. So in order to run Python locally, we're gonna have to go to our command line. Let me pull up a new one here. Open tab, there we go. So be our Python tab. So to start Python, you just have to type Python 3. So this is going to start the third version of Python. And now we are in a Python shell, and we can do glorious things like use it as a calculator. So what is 6 times 6? It's 36. Excellent. Remember we had that print statement before? Print hello world. Now we should have hello world printed below. Awesome. Awesome, awesome. Let's see. If you do not have Python 3 installed, you can install it on a Mac by going to the Python website. Download Python. Download Python. So from python.org, you can download all the versions of Python, put it on your Mac or Windows machines. It should already be installed if you are in Linux. If not, you can apt install Python 3. There are instructions on the page here. In Mac, I actually recommend using something called Brew. Brew is a package manager for Mac OS. Let me see if I can pull it up. Brew package manager. The missing package manager for Mac OS. So if you're running Mac OS and want Python 3 installed, I actually recommend using Homebrew. Install Homebrew and then type brew install Python 3 from your command line. That'll get you all set up. We can go over this later if anyone has any issues getting that installed. But on Windows, just download from python.org. So let's create a program. So right now what we're doing is we're in the Python console and we're just typing in Python commands line by line. And that's fine and everything, but we can actually make a program, like a script, save it, and then run it as many times as we want. Okay, let's do that. So in order to exit the command line here, the Python interactive shell, we run the exit command, or the exit function, I'm sorry. So remember, every function has an open and close bracket, and we're out. Okay, so let's write a Python program. So I'm gonna make a directory, example Python. We're gonna go into Nano, and this doesn't have to be Nano. If you like to use another text editor, feel free to use that. I'm using Nano because it's easy to use, and a lot of people like it. I'm not gonna throw you all into Vim or Emacs. So Nano, let's see what the example says here. Hello.py. Okay, perfect. We're gonna do another hello world. Hello.py. So if we write another Python function here, print hello world, push Control X to exit, and below it says, you want to save the buffer? So yes, we do. And we push Y, and then the file to write, push Enter, it'll automatically save as hello.py. Now if we run Python 3, hello.py, we get our hello world output. Cool, awesome. And we can make this a little better too, because that was not really how you're supposed to write a Python program. I just wanted to show you the most basic line, one line, you got a Python program. Usually what you want in any script in Linux is a shebang line. And what a shebang line does is it gets rid of the necessity of us typing out Python 3 before running the script. So we'll go into nano. We'll go into hello.py. And at the top, and this is all on the webpage, I'm sure. We're going to go pound, exclamation point, / user, USR, sorry, not user, Unix system resources, bin, env for environment, Python 3. That's our shebang line. That tells it we're going to be using Python 3. We're going to save it. Oops. We're going to save it as hello.py. Perfect. Now we're going to use chmod, add executable rights to this file. If we do ls again, we see it's screen, so we can execute it. / hello.py. Now it'll just run by itself. We don't even have to type Python 3 anymore. It knows to use the Python 3 interpreter because we put that shebang line at the top. And now we have our complete hello world program written in Python. Let's see. So, all right, the next flag is to then do what we tried to do above in the website that failed, use the import requests, and then print out the results. So why don't I do this really quickly? I'm not going to give you the full flag here. But what we're going to do is we're going to import the requests module. And we're going to make requests to, let's say, google.com. Is it requests or request? I can't remember. Yeah, requests. Requests.get. www.google.com. Okay, so that's going to get us Google. And we're going to store that in a variable R. And we'll just, so in Python, a good debugging technique is that you can put anything in the print statement. You don't have to put text in there. You can put an object, and it'll print what it can about the object. So we're going to print R, and we'll see what happens. So hello.py, response, oh. Yep, so we got a response from Google. And you can look at what you get in more detail. What I would recommend doing now, though, is instead of trying to figure out in your coding what you can do with the response from requests, what you can do is you can Google for Python requests library. And we should get, here we go, HTTP request for humans. Here we're going to get the entire user guide, all the usage, et cetera, et cetera, et cetera. And this is how we're going to figure out how to use the requests module. So here's a nice quick start. We import requests. And this is what we were doing before. Our request get equals R. And as you can see, there's a few other functions here. We can post. We can run a bunch of different web functions here. And if we want to see what our response is, it'd be r.text. Okay, let's do that. So let's look at r.text in our response. So we're going to go back into Python. And we're going to print r.text, just like we saw in the documentation. So I'm trying to basically say, documentation is your friend, error messages are your friends. These are things new players really try to avoid, and they don't like it, and they don't like the documentation, they don't like the error messages, but these things really help. So we're going to save, and now we're going to get Google's webpage. There we go. All this junk that just got outputted is the same thing that gets sent to your browser. It's just a bunch of HTML, and you can see it's HTML because at the end we have body HTML at the end. And if we were to do this with samsclass.info, which uses more, let's just say, traditional HTML. I'm not going to say add a date or anything like that. www.samsclass.info. We should get something that looks more like regular HTML. Assuming it loads. Ah, there we go. So this looks like more like HTML. And you can see this is Sam's site because it was written by hand in HTML. Bitcoin power consumption at the bottom. Yeah, that's Sam's class in HTML. So let's look back at the website here. So yeah, so you would use the same idea here to figure out what the status code is when you try to get Sam's class.info. Let's go on to the next section, which is strings and bytes and files. So let's go over strings first. So one of the major differences between why Python 3 exists as opposed to us continuing to use Python 2 is because Python 2 did not handle Unicode very well. So a bunch of our international friends became very upset using Python 2. A brief history of computers and the way that text is stored in them. There's a group that comes out with these standards. One of these standards is called Ascii. Ascii is a single byte, and in the West we use it to display characters, A through Z, 1 through 3, etc., etc. And that's great. We can store the entire alphabet in 1 byte. But what if you're working with something like Japanese, where you still sometimes use Western Latin characters, but sometimes you also have hiragana, katakana, and of course kanji. Now you're talking about thousands and thousands of characters, and you can't store that in a single byte. So a bunch of our international friends became very upset at Python 2 for not supporting this out of the box natively. So Python 3 comes around and supports these Unicode strings. So let's play around with some of these strings. Simple string processing here. So we're going to make a hello world greeting, and then we're going to play around with that greeting. So we're going to create substrings. We're going to figure out how to do substrings. So I'm going to make a new Python script here. Actually, you know what? We're just going to go into the Python shell. So let's make a greeting here. Greeting equals hello, wonderful world. Now, if we print greeting, we get that whole statement that I just printed, or just set the variable to. Print greeting and hello, wonderful world. Awesome. Now, let's say I just want to know, I want to skip the first 3 characters. Anyone familiar with the old C syntax for arrays will know exactly what's going on here. You do an open bracket and a close bracket, or square bracket, I should say, indicating a list or an array. And you add a colon and a 3 and a colon. Let's see what happens. I'm missing part of my statement. What happened is I specified the string from the 3rd character onward. So we skip this one, the first character, the second character, and the 3rd character, and we start at this character. So strings start at 0, the 0th character, right? So if you want to do the full string, you would be 0 colon forever. And then if we wanted to, let's say, get rid of the H, the first character in the string, we would do 1 colon. Let's say we want to get rid of the first 2 characters, the first 3 characters, and so on. And we can do this in reverse too. Like, let's say we want to get rid of, we only want the first 5 characters. So if we do colon 5, it's going to count the first 5 characters and then ignore everything else. Now we just have hello. Okay, so Miriam's having some issues with pip. I would recommend actually installing requests if you have. You can use pip to install requests, depending on your operating system and your environment. That should actually be installable via the apt command if you're like in Linux, or brew if you're in Mac OS. So let me exit out here for a second. So if you're having issues getting requests, you would do something like apt search Python 3 requests. And we should get the module. One of these is what we're looking for. Python 3 requests. Here we go. So if you want to install Python 3 requests on a Debian or Ubuntu based system like what I'm using, you would install run this command. Hold on. Let me scroll down.
If you are using a Mac with Homebrew installed, you should be able to brew install pip also.
Yep. Or pip 3. Make sure, because like I said, this is the 3rd version of Python. And with all these versions of Python going around, there's some confusion about what is the default Python. So make sure you're installing pip for Python 3. But if you are in Debian, you can install apt install Python 3 -requests to get the requests library. Anyway, to continue with strings. The only thing we didn't go over, so we went over how to get the beginning of the string. We went over how to get the end of the string. What if you want the middle of the string? So let's do this again. Let's create a greeting. Hello, wonderful world. And let's print the greeting. Let's do the characters between 5 and 10. Now we get 1. So if we count, we go, this is the 0th character, 1, 2, 3, 4, 5. So we're starting here. And then we go to 10. So 6, 7, 8, 9, 8, 9. So it's going between 5 and 10, 10 being the last, 10 minus 1 essentially. So a common error in programming is this off by 1 error, because sometimes you have systems like this where you don't include the last element, only elements before that element. And so some programmers get confused, but that's how you do the middle of a string. So you would have something like this, where you have 5:10, meaning start at the 5th and before the 10th. Let's see, creating echo.py. We're getting into sockets. We're getting into sockets. So sockets, for those who are new to network programming, is very low-level TCP communications. So what we were using requests, which is kind of high level. It assumes you're running a web server. It won't connect to like an FTP site, for example. What sockets allows us to do is do low-level communications between two systems. And we're going to get some strings using sockets. So I'm going to exit out of here. We're going to create a new file called python.py, or sockets.py, or sock.py. I think that's even better. Sock.py. We're going to copy and paste some code. There we go. And we'll ignore the shebang for right now. So what's going on? So we're importing the socket library. We're creating a new socket. We're connecting to Sam's attack site on port 10101. We're going to receive some information from that socket. We're going to send it a string, a byte string. So that's what this encoding is doing. We're encoding it into a series of bytes. And then we're going to read the response from that server and then close the connection. So let's see what happens when we run this. Let's run Python 3, sock.py. We're going to slowly wait for the response. Something's happening. Is attack down, I wonder? It should not take this long. Maybe we should have set a timeout. I will set a timeout. Yeah, we're not.
That's the one I'm talking about. Like, I could not get that to work. It just hangs and just sits there forever.
Yeah, it is just sitting there forever. It is not working correctly. Let's debug this. I think this is something on the server side. I think Sam's server got hacked. again by someone who wasn't me this time, I swear. So we're going to use netcat.
That's what all the hackers say. It wasn't me this time, I swear. I didn't do it.
I know. 10101. And we are not getting anything.
Okay, I'll look into it.
Actually, yeah. So Sam's server is broken. However, if we were to do, let's do Python 3. If we were to import socket, s equals socket here, and let's do s. We're going to do the socket we created. We're going to connect it to Sam's class.info on port 80. And then we are going to send it, let's say, get / so we're going to get the base, we're going to send it a web request to get the root directory.
Do you not need to add that Sam class, or is this?
Oh, no, I'm just showing you how sockets would normally work.
Oh, gotcha.
By creating a little web browser here.
All right.
Dot encode, \n dot encode. I think that'll work. Okay, we got something back. Print s dot receive 1024 dot decode. We didn't get anything back. Shoot, maybe because we're running too slowly. But that's how you would essentially make a web socket. So what I did is I created a basic TCP socket. I connected successfully to samsclass.info on port 80, and I did send it a GET request, and I'm just not getting anything back from the server right now for some reason. Who knows why? Maybe if I send it junk. Oh, it's broken. It closed the connection on me. Oh well. But that's how sockets work. The important thing is you just understand the difference between a socket and a request. So a request, like I said, is very high level HTTP, whereas a socket is very low level TCP connections. Where if you could use it to get a web page, but you would have to send in the full HTTP request and everything. Let's see. So the first flag, we are going to connect to samsclass.info on another port and grab some flags. And then we are going. It's
working right now.
Yeah, when it works, we'll connect. And the next flag is we're going to send a number. So what's going to happen is that we're going to have to interact with the response that the server sends us. So the server is going to send us a response, and we're going to have to do something with that response. So let me show you something cool that you can do in Python, which will help. So let's say we have a string here, str equals 35. Print str. So we have a string that has a number in it. Now let's say we want to convert. Now if we were to do something like print str times 3, we get 35, 35, 35. What's going on? So because this is a string, it treats it like any text. So if I were to do print a times 3, we're going to get 3 A's. That's what's going on. So we need to somehow convert that string into a number. And to do that in Python, you would do something like int str, right, str times 3. There we go. So this is how you would convert a string that you get back into a number. So if you have a number that's a string, you can convert it into a number that Python can use to perform calculations on. Anyway, that's your pro tip. Is there another pro tip? So the other gotcha for Python is the encode and decode that's used a lot in some of these examples. And so just remember that the idea behind Python 3 is that we're working with Unicode. So if we have a string here called hello world, we have a string like that, Python treats it as a string object. However, if we encode it, it's going to turn it into a series of bytes. And that's what that B means here. It's a bytes. It's a series of bytes. And what's going on is that hello world can have characters that are multiple bytes long. So you can support things like Chinese characters or Korean characters or Greek letters and emoticons or emojis, I should say. But if you want to send just a series of bytes, which is often what we're doing with this networking that we're engaged in, you have to convert it into, you have to encode it into bytes. And then if you have a bunch of bytes like this, you can define bytes like, you can define bytes like that. You can then decode back into a string. So if you want to convert between strings and bytes, that's what the encoding and decoding is doing. Loops in Python. Okay, so Python is
101 should be back up now.
Excellent. Thank you so much, Sam. So the weird thing about Python, if you're used to C or C#, you'll know that loops and subcodes usually go into brackets. But Python wants to automatically make your code clean. So instead of using brackets, it looks purely at the indentation to make sure you're indenting the code. And that's how it tells what is supposed to be within a for loop. So let's make a for loop right here. So I'm going to type for I in range 3, colon. Print I, and we're going to tab this. And then I'm going to push enter again. And now it ran the for loop here. And let me put this into a file because I think that'll make more sense what's going on. But you'll notice we didn't have any brackets. All I did was add an indentation here for Python to note that this is part of the for loop. So nano loop.py for I in range 3, colon, tab, print I. We're going to save and then run it in Python. If I can spell Python correctly. Python. There we go. So we did the same thing again, but in the code. So if we look at loop.py. So indentation matters a lot in Python. And indentation can be spaces, it can be tabs, but never cross the streams. That is a very frustrating trap for programmers. One programmer might prefer tabs, another programmer might prefer spaces in their code, and then they start working on the same Python file, and all of a sudden all the code breaks because one of the programmers decided to use spaces, not realizing that those were tabs. So if you're using tabs, always use tabs. If you're using spaces, always use spaces, and always keep the indentation the same because Python really depends on that indentation to figure out what is in a loop and what is not in a loop. Let's see. No. Yeah, Python's retyped. Yep. So flag, add and subtract. So we're going to connect once again to samsclass.ad.samsclass.info, grab some numbers, and add and subtract them. ASCII encoding. So remember I mentioned something about ASCII before, about it being between 0 and 255. Like I said, so Python 2 defaulted to ASCII, and our international friends did not like that and became frustrated. However, ASCII is still useful today, especially when you're working with older protocols. So if we want to convert between ASCII and Python 3 strings, we can do so by using the encode and decode bytes, which is what we're doing here. But let me show you something about escape strings, because we're going to be using those a lot. And I kind of see what Sam's is going for here. So Python 3, we're gonna go into the shell again. So like, let's say you want specific ASCII characters. So the ASCII character for the capital A is hex 41. So let's do a bytes, or we're gonna call this the variable B. We're gonna make a byte string or a byte list. And let's say we want the character, we could do AAAA, right? Or just AAA, right? We could do that. And we could print B and we get a bunch of A's in our byte list. But let's say we want to specify the character by its hexadecimal value. If you're familiar with C, it's very similar. We do open quote, \x 41, \x 41, \x 41. And if we print B, we should get AAAA again. Haha. So what we did here is we said, we're going to define this array of bytes as AAA. And we verified it by printing it out. But now we defined it using the hexadecimal characters, using the \x escape sequence to say 41, 41, 41, and we got AAA again. Because that's, like I said, 41 is equivalent to the hexadecimal number. So A is equivalent to the hexadecimal number 41. All right, and this is important to know because in strings can have multiple bytes per character. So if we create a S equals, let's say, access 41, 41, 41, print that out, we get AAA again. But what if we do something a little more mischievous here, like FF? We get a weird symbol here, right? We get this kind of Y umlaut symbol. And then what if we do \x 40? See what happens now. Yeah, we're getting a lot of weird stuff here. So if we were to convert that to strings, remember I mentioned the encode decode, we would encode it as a series of bytes. And now we're getting totally different stuff outputted again. We're getting AAA, we're getting hexadecimal C3, BFF, at. I mean, there's a lot going on. Strings do a lot of magic behind the scenes to make it compatible with all these different systems, UTF-8, etc. So if you are specifically wanting a series of bytes to be sent to a server, you want to make sure that you are sending up those bytes. I know it's a bit mind-boggling at first, and a lot of people resisted moving to Python 3 because the strings were so much more complex than Python 2's simple ASCII. But like I said, this makes international writings in Python much easier at the expense of those of us who only use the Latin alphabet.
Also, please stop us if something, I know we're covering a lot, but if something doesn't make sense, please make sure you ask us, because you know your understanding on this section is largely going to be it's going to be largely involved in the next section. Typically, they're not our sections you can skip around, but these things that Caitlin's teaching you right now are some good fundamentals. So make sure you reach out to one of us or ask a question if you're having problems.
Right. I'm really taking my time going over this because this is the trap for a lot of people just getting into Python 3, is understanding the difference between strings and encoding and bytes and what's going on. Why do we have to encode a string that looks perfectly fine into bytes? What kind of weirdness is going on? And I'm here to tell you, it is really weird. And it is totally confusing, and it confuses all of us at first when we first jump into Unicode. And so there's a few other escape characters we can throw into some strings here. So the -u specifies a Unicode character. So if we have s equals \u 000041. Oh, that did not work. Uniscope cannot decode the byte for some reason. What am I doing wrong?
Hey, Caitlin, let me interrupt you for just a minute. Some people are having trouble because one port gets overloaded and there are backup ports. If you can just look at the instructions below flag VP101, why don't you put it up there for a minute in the instructions for VP100? Yeah, go up.
101?
Yep, right there. There's extra
yes.
ports. Check those. If the first port is busy, there's 2 backup ports for each challenge. So use those.
Sam, when this is over, I'm going to have to work with you to figure out how to get multiple people connected on the same port simultaneously.
Yeah, somehow it has some limit that it hits. Yeah, it'd be good.
Yeah. We'll work on that. Yeah, so if a port is down, there are other ports to try. And if you are doing ports very simply, like if you open a netcat port, let me go into another tab here. So let me show you what's going on and why it's overloaded. So if I open a port here, so I'm going to open up tmux so I can show you 2 things at the same time. So if I do sudo netcat listen on port, let's say 82. So now I have netcat listening on port 82. If I try to open up that same port again, it somehow works. It shouldn't be able to work. Oh, well, that's odd. That should not be a thing that happens. Okay, just ignore me. So sometimes ports can be set up that only one person can connect at a time, essentially. They apparently are doing some magic in the most modern version of Kali too.
Yeah, I think what happens, it's not that it can only handle one customer, it's that students with broken scripts perform essentially a slow loris attack with partial connections and freeze it.
Well, that's the other thing too. If you have a script that connects and then is slow loris, essentially, so you only have one, so you have a connection that doesn't end for a very long time, and another person tries to connect to that, then it will break. So if I were to open up a netcat listener on my system and I'm already connected to another person, I can't open up another netcat. I can't create another netcat connection to that. So let's see. So if we do, let's copy this escape character here. Oh, because I'm using single quotes, maybe? No, that's not working, Sam. Part of your code, part of your Unicode is not executing correctly in modern Python. Yeah, that's working. That's failing. I would have to look up Unicode characters, happy face. Let's look up some emojis. So if we look here, we should be able to get the Unicode number, UTF-8 encoding. Let's do UTF. Okay, so we should be able to create a Unicode character by copying this. There we go. Oh, no. There we go. Now we got a Unicode character. And it's a smiley face. So what did I do? I went to the Unicode lookup page, which has all the Unicode information for the smiley face character. And I copied this value here, which is the UTF-32 encoding of this character. and I put it into the string. So I said, this is the character \U, 26.3a. And indeed, I got, I don't know if you can see that because it's kind of small, but I got a little smiley face in my terminal now. Anyway, that's how you put emojis in your shellcode. And that's the idea behind Python strings, is that you can have these characters that go beyond ASCII. But if we were to encode as bytes, you'll see that it's going to look completely different. Yeah, so now we have E298PA. If we were to send that over as a series of bytes. If this is confusing, don't worry. It's confusing to all of us. I would just say play around with it until you understand, the difference between bytes and strings. Let's see, what's the next flag? Find the 8th character Unicode point for capital sigma. Okay, so if we were to do, so basically what you're going to do is you're going to do exactly kind of what I did here, which is the \U escape character for Unicode. And you're kind of going to go through the different Unicode characters. So like, let's say I want to figure out what 3b is. I could do that. And then print string, my Unicode string. Now I get a different happy face. And if I do the next character up, I get, I think, a sun. Yeah, I get some sunshine. Ah, wonderful. So the idea is to play around with these Unicode characters and figure out what you can find. You're trying to find the sigma character and a hamburger. So playing around with more fun emojis. So I'll take a break. If there are any questions or anyone's still having issues setting up, I can help.
I have a question on the
Yes.
on number 2.
Okay.
The up above, where you send in value, or you're not sending just the message in there. You're supposed to send like basically a math, +1.
Yep.
So like I looked up the string to int where you do the print and an int and parentheses and whatnot. But what I'm trying to understand is, where does that go? Does it go within the quotes of where the goodbye, like where the hello was?
So what we want to do is we get a number back from the server. So the server said, hello, your number is 90. So we're going to come up here where we cut off the string. Yeah, so we'll cut off the string right where we get to 90. And we're going to create a substring that only has 90. So let me do a quick example here without connecting to the server. So we're going to make server string. Say, your number is 90, right? And let's say I only want 90 from there. So I could do server string. I am too lazy to count, so I'll just guess. Let's see what happens at 9 : more than that. Let's do 12. 15. Ah, there we go. So at the 15th, so grab the 15th character onward, I get a 90. Okay. Now I need to convert that 90 into a number. So server num equals int. Server string 15 onward. So if I print the server num, I now get a number. So now I can add 1 to the number. So response num equals server num +1, which should be 91, I believe. Yep, I took math classes. And then we're going to send that back to the server. And we're going to have to convert that back into ASCII. So in order to do that, we're going to make a response string. We're going to say, and that's going to be equal to, we're going to convert the integer into a string, and you do that with the str function. Response num, sorry, response number. Str call is not, hold on one second, let me look this up. Like I said, you always have to look stuff up. Convert Python, convert integer to string. I thought it was str. What am I, or is it ord? Is it ord? No, yeah, no, it's str. Remember str. Oh, because I already used it as a, I'm sorry, I made a mistake. Let me exit out of this. So str, oops. So what happened is that I created a variable called str, and it's getting very confused.
Oh, that's a no-no.
Yeah. So it didn't know if I was trying to call the str variable or the str function, and so I got confused. So we'll just do this once again. So server string equals the number is 90. And then we'll get the server number again. And then we'll get the response number. And now we'll turn it back into the response string. Excellent. So if we print the response string, we get a string that is 90. That's 91. So if we were to do times 3, we'll get 91, 91, 91 to show that it's actually an Ascii string, or sorry, a Unicode string. And if we want to send that up to the server, we would then encode it as bytes. But we get 91 back. Oh yeah, never mind. I'm reading this wrong. So yeah, so we get the character 9 and the character 1. So this is 2 bytes long. And I believe we'd send that back to the server, and that's how we would finish that problem. Right, so yeah, you just send back those 2 bytes. So it's a bunch of converting between, you get a string from the server, you cut off that string just so you get the number that you're trying to work with.
Okay.
You then convert that string, that number, so you then add 1 to that number, convert that number back into a string, and encode it into a series of bytes, and send it back to the server. It's involved. In Python 2, this would have been much simpler, but because this is Python 3, we're dealing with Unicode strings.
I hate coding. Thank you.
No problem. I know it's, once you get over this, the rest of Python is going to go much more smoothly. Once you wrap your head around how the strings and everything works. All right, any other questions? Still get an error.